Okay, today we're going to talk about patterns of linear relationships. When given a table of values, if it is a linear relationship, if it graphs as a straight line, in other words, um, it will have the same difference between each of the y values, which is what we discussed in a previous lesson here. We use this difference, uh, we also use this difference to find the value of y when x equals 0, if we don't know that already. Now we can take those two values, the y difference and the value of y when x is 0, and we write a linear equation which will give us all those data points on the that we've been given the data table, and will give us a straight line. Let's just see how that, it's a bit confusing. Let's just try a couple examples here and see how that works out. Well, first of all, if it's a linear relationship, we know that if you subtract each of those pairs of numbers, 2 minus 1 is 1, 1 again, and 1 again. That's one of the first steps of checking if it's a linear relationship. The second step is we check these ones. 12 minus 7 is 5. And those pairs also give you 5 when you subtract them. So the difference is equal to 5. Okay, so now what we need to do is we need to find when x equals 0. When x equals 0, that's one step backwards. We've been adding 5 to go to 2, 3, and 4. So to go to 0, we need to subtract 5. So what we do is we subtract 5 there. Just one group of 5. So it's just taking one step down to 0. And that gives us 2. So those two numbers here are the key numbers we need to use to write our equation. Okay. And, okay, let's see here. So what we're going to do is take, and we've got an x, and the x here, let's just put that in here, x plus, okay. And now what we do is the 5, the difference between each of those sets, we put in front of the x. So we're 5 times whatever the x is. Each time is a group of 5 added on there. And what we do with the 2 is we add that to the end. So just to test this out, let's take a look. If I take and put 1 in there, 5 times for x, put 1 in for x, so substitute each of the x values in for the x and see what you get when you multiply by 5 and add 2. We find that 5 times 1 is 5 plus 2 is 7, gives us the y value of 7, perfect. Put 2 in there, 2 times 5 is 10 plus 2 is 12, and each of those is the same thing. The last one, 4 times 5 is 20 plus 2 is 22. So that works. Let's try with the next couple examples. Try to ingrain this. Okay, we just check again. Make sure the difference here is 1. It is 2. All the same. This difference here is 3. And we check those, and those are differences of 3 as well. Beautiful. So what we need here is we need the difference. So the difference, okay, in y values is 3. It goes up by jumps of 3. So let's now what is it when it's 0? When x is 0? Well, we know that when x is 0, it gives us that information already. We've got that right here. When x is 0, y is 13. So that's our second value we need. Well, let's write the equation then. So write the equation, and it's y equals, okay, the difference was 3, so 3 times the x plus, and what was the 0 value? Like when the x is 0, what is y? Well, that one is 13. Let's just check that out here. Put 0 in, x 0 for x, so 0 times 3 is 0, plus 13 is 13. Good. And each of those you plug in the x value of 1, 2, 3. 3 times 3 is 9, plus 13 is 22. It all works out and gives us the y value. So that's the equation that gives us those numbers and also the straight line. Let's do the third and last example here. One more time, I'm just going to check that these are differences. Yeah, they're all differences of 1. Okay. And what is the difference here? This difference is 6. And these all work out to be, oh, I'm sorry, not 6, negative 6, because 28 or 22 minus 28 equals negative 6. Remember, we take the the one that follows, and subtract the previous one from it. This gives us, it's going down in groups of 6, which makes sense that it's negative 6. Okay, so what we're going to do here is find out. So the difference is negative 6, so the difference, okay, in y is negative 6. That's going in groups of negative 6. Okay, now it's going down. Now what about the 0 value? When x is 0, what will y be? Well, what will y be? Will y be smaller or bigger? Well, basically what we're going to do is we're actually going to take that y value, and what we're going to do is take, so that y was 28. Remember, we always subtract the difference, so subtract, the difference was negative 6. In this case, we're going to add 6, because it's going to be 6 bigger. So 28 plus 6, which equals 34. So let's write our equation now. We've got y, so let's put down our y, equals, our difference is negative 6, so negative 6, and we've got times x plus, and the answer to that is 34. Let's just test it out with our data we've got there. Put 1 in there. 1 times negative 6 is negative 6, plus 34 is 28. Good. 12 is 22. 34 minus 12 is 22. Yep, this all works out perfectly to work with that data. It gives us the y values, and once you plug in those x's. And there we have the pattern, written as an equation for each of those 2 examples, as well as the one above in example 1. I hope that helps a little bit.